Okay, so same directions as in our previous two examples. We want to list the first four terms of the sequence and determine if it converges. Except instead of giving our sequence as a formula here, it's given to us recursively. Right? Cn plus 1, the next term, is equal to 1 plus half the previous term. Okay, so let's do that here. We are told here C0 is 2, so the initial term is 2. So we want to compute the next four. So C1 would be 1 plus C0, which is 2 over 2. So 1 plus 2 over 2 be 1 plus 1 is just 2. And so that means that C2 would be 2, right? And so C3 would be 2. And so C4 would be 2, and onward forever. So this is the not so exciting sequence 2, 2, 2, 2, 2, 2, 2, 2, 2, 2 forever. So, of course, it definitely converges to 2. It definitely converges to 2. Now, if we change that initial value, we can keep the same recurrence relation and yet generate a different sequence. So consider the sequence dn plus 1 equals 1 plus dn over 2. And let's say here that d0 is equal to 1. Well, let's look at our first few terms here. And again, take a guess. Does it converge or does it not converge? Okay. So d1 would be 1 plus 1 over 2, right? Which would just be 3 halves. Right? 1 plus 1 over 2, so d1 would be 3 halves. d2 would be 1 plus half of that, be 1 plus 3/4, will be 7/4. And then d3 would be 1 plus half of that, which would be 7/8, give us 15/8. And finally, d4 would be 1 plus half of that, so that would be 15/16. So that's actually going to be 1 and 15/16, or 31/16. So you might not quite see what's happening here. So you may need to look at these answers as decimals to kind of start seeing a pattern. So we have, first of all, 3 halves, which is just 1.5. Next we have 7/4, 1.75, and then 15/8, 1.875, 31/16, 1.9375, and we continue on and on and on and on and on. And so if you think about these numbers here, 3 over 2, 7 over 4, 15 over 8, 31 over 16, you actually start seeing a pattern in these numbers, in the denominators there, that might help you also to lead to kind of making a guess of what's going on here. And that is that this thing is also converging to 2. Also converging to 2. Also converging to 2.